Professor David Clough. This is the first of a series of 4 boot camps focusing on the Excel spreadsheet and VBA programming language and applications to chemical engineering problem solving. So these will be in a series of screencasts. This is the first one, as shown here. And although you may have a fair amount of experience with Excel and even with VBA, we think it would be to your benefit to work through these, as they may serve as a review and they may actually introduce some concepts or skills that are new to you. So you'll see here the outline to the first boot camp, and it's primarily focused in 2 different areas. One is the basics of the Excel spreadsheet, manipulations, formulas, etc. And then the second is the creation of plots with an emphasis on the kind of plots that engineers typically use. As we go through the boot camps, there will be certain spreadsheet files that are available to you as starter files. They will just help us save some time in creating the initial part of a spreadsheet that we're going to work with. And we'll denote those as we go along and suggest that you open them when we do. We're going to start out with the basics here. First, taking a look at the main window of the Excel spreadsheet and the different nomenclature that we use to describe parts of the main window. The area of rectangular cells we call the worksheet. Here's the home cell up in the upper left-hand corner. And then just above it, we have a little area we call the name box. Across the top, we have the main area for commands. And this is called the ribbon. And the commands are divided by menu items here, such as home, insert, draw, etc. And selecting one of those menu items will reveal a different ribbon, which is composed of groups, and then such as this one here, alignment. And then within each group, in the lower right-hand corner, you have the option to expand it, and there are a series of commands within each group that you can click on and invoke. Up at the top, we have the title bar, and at the bottom, we have the status bar. Each worksheet has a sheet tab with its title. And then down the lower right-hand corner, we have a sliding zoom control. And then we have sliders horizontally and vertically to help us move around the worksheet. So we'll be using this nomenclature as we go along. Next, what we want to do is review with you a series of settings that we prefer that you make to Excel that will help as we go through the exercises in the 4 boot camps. So I'm going to pop over to the spreadsheet for a moment to take a look at those. Go to the Home tab here. And depending on the screen resolution that you work with, mine is not particularly fine to make it easier for you to see things. How the ribbon is presented to you may be in more or less detail. So as I search for a command, it may be more obvious to you if you're using a display with a greater resolution. So we're going to go to the File item on the menu, and down at the bottom I have More here, and then I'm going to pick Options. It's possible that options may have already been available to you, but I'm picking Options. And then we're going to look at a series of settings here. First, if we click on Advanced, we have as the first one, after pressing Enter, move selection. And yours may be checked, and we don't want that checked, so you can remove the check from that. And then there's another option here called Add-ins. And toward the bottom, we can click on Go and get the Add-ins dialog box. And what we want to make sure of here is that we have the 2 analysis toolpacks checked and the solver checked. Those may already be that way for you. And then click OK. And then finally, here, for settings, we're going back to Options. We're going to pick the one that's called Trust Center at the bottom. Trust Center Settings. And over on the left, Macro Settings. And we want to check the option Enable VBA Macros. Now it says here, not recommended. And that's a warning that has to do mainly with using macros that others create, not ones that you will create. So it's not that meaningful a warning for you. So click Enable VBA Macros. And then if you are unable to do that, you can pick one of the disable options and live with that, although it's not ideal. And then the last one we're going to look at in the options window is Customize Ribbon. And over on the right, we want to make sure that we have the developer checked. And if you check developer, click OK, see that developer is an item on the menu that gives you a specific ribbon that we will be using a little bit early on, but we'll be using it a lot later on when we get involved with VBA. So those are the settings. Now we're going to go through some very rudimentary skills and manipulations with Excel. And these may be well familiar to you, but maybe not all of them. So I'm going to open a spreadsheet. Let me find it here. And it is called Selection Practice. And it should be among your files for Bootcamp 1. I'm going to open that. It comes up looking like this. And then we're just going to go through some rudimentary operations. We have cells on the spreadsheet. We can select a cell within view by clicking on it. And when we do that, the name box has the address of the cell in terms of column row, column G, row 3 in this case. We have the home cell up here, which has the address A1. So we can very easily move to another cell by just clicking on it. And we can also move to another cell using the arrow keys on the keyboard, down one and to the right one, up and to the left. So we can use the arrow keys and we can click on it. Also, we can get to a cell that is a long ways away by coming up to the name box, clicking there, and typing, for instance, T40, which is not in view right now, and hit enter. And it shows us T40 down here in the lower right-hand corner. And then if we want to go back to the home cell, we can do a control home with the keyboard. And it'll take us back to the home cell A1. So we can get around to different addresses in that way. We're next going to talk about what we call jumps, and that is starting with jumps within filled ranges of cells. So I'm clicking on the cell B2 here, and I'm going to bring the mouse cursor in just below that, right on the lower border, and double click, and what we see is it jumps to the cell that is filled at the opposite extreme. If I click the upper boundary here, it jumps back. If I come down to this 39.93, click the right border, it jumps over here, and double click the left border and it jumps back here. So that is using the mouse cursor. One thing I'll mention just from my own experience in teaching many short courses on Excel is that the people who use the touchpad and not the mouse at certain points have a hard time keeping up as we go along, because the touchpad is not as efficient for many of the manipulations that we use in Excel. If you're using the touchpad, feel free to go ahead and continue to do that. It's always possible for you to pause the video and catch up if it's going a little bit slow for you. Now, the other thing that we can do here is when we're on a cell like B2 here, first, obviously, if we hit the arrow key, we go down one cell, the up arrow key, we go back up. But if we hold the control key down, we get a jump, and control up, we get a jump back up. So we can use the control and arrow keys as an alternate to double clicking on the boundary of the cell. And then if we're down here and we do a control down, it takes us all the way to row 759. So it's very useful to use these jumps when you're dealing with significant amounts of data. So I'm going to do a control home here to take us back up to the top. Now, if instead of doing a jump, if I hold down the shift key and hit the double click the lower boundary, you'll notice that I get a selection, right? Instead of a jump. And if I come down here to cell B10 and instead do a control down, control shift down, holding down control and shift, then I get a selection all the way to the bottom. And you'll notice that it shows me the bottom of the selection. Now, sometimes we want to see the top of the selection, so a typical way to do that is to move over and grab the slider and slide it to the top, and that's one good way to do it, maybe. Another is to make that selection and hit a tab key and then a shift tab, and that takes us right to the top of the selection. The reason that that works is to be shown here, is that if I select this cell and I hit a tab key, it moves over one to the right, and then if I hit a back tab key, it moves back. So if I have 3 cells selected here and hit a tab key, it moves the active cell, it's what we call it, the active cell, down. And if I hit a back tab or a shift tab, it takes me back to the top. The advantage of doing that, if I go down to the bottom here with tab and back tab, is that it brings the top back into view. Okay? Now, if we're dealing with blocks of cells, we can pick cell within a block and do a control A standing for all, and you'll notice that it selects the entire block, but it holds on to the active cell as the cell that I had selected when I did the control A. So that's control A. If instead I pick that cell and do a control asterisk, which for most keyboards is a control shift 8, then notice it does the selection, but it returns the active cell to the upper left-hand corner, okay? Now, another thing that turns out to be very useful to do is to be able to select what we call discontiguous blocks on the spreadsheet. And what I'm going to do here is illustrate how we can select just the first and the third columns. Now, where this comes into play frequently is when you want to make plots and only involve certain columns of a data block. So let us start by selecting B10 and do a control shift down, and then a tab and a back tab to come back to the top. And then what I'm going to do is hold down the control key and click over here on D10, and I am not letting up on the control key, it's still down, and then I do a shift down and I get the 2 columns. Now if I do a tab and a back tab, it brings me back up to the top, and I have those 2 columns with the active cell being the one at the top of the second column. At that point in time, for instance, I could plot the third column versus the first column. So that's doing discontiguous blocks by using the control key. Another opportunity I'll point out for that is that, for instance, if I want to select that block of cells, then hold the control key down and select that block, still holding the control key down, select that block, and finally select that block, I can select a set of different blocks of cells, and then, for instance, I could apply a format to whatever is displayed there or would be displayed there at once with one operation, instead of having to format individual blocks and then copy the formatting to the next block. So that's another reason to be able to select discontiguous blocks. Okay? So let's move on now and talk about copying and moving cells. So I'm going to select this cell over here. And I'm going to initiate a copy with Control C. And you'll notice a moving outline around it. I'm going to pick a destination over here in E2, and I'm going to hit the Enter key. And then that provides us with a copy. Now, since I'm going to be doing this in a variety of ways, I'm going to reverse that up here with the Undo button, or Control Z, Control Z if you prefer. That takes us back before that step was performed. Okay? Now, another way that I can do this is that I could, instead of using the Enter key, I initiate the copy, and then I pick a cell and do a Control V, and another cell, Control V, and I do multiple copies. Okay? And Control V stands for paste. And when you do a copy, you want to use Control V or paste when you're going to copy the cell to multiple locations. If you're not going to do that, then I'm just going to delete these. If you're not going to do that, then you are going to just do a Control C, pick your destination, and hit the Enter key. Now I've had some formatting carried along here, so let me get rid of that. Back to where we started. Now, another thing that I can do here is if I pick a couple cells here, and if I come in with the mouse with the Control key held down, there will be an arrow on the boundary of the selection with a little plus sign just above and to the right of the arrow. And then if I move that over and release it, I get a copy. So instead of dragging and moving the cells, it provides a copy when I hold the Control key down, all right? And that's a very typical thing in the Windows operating system that shows up, for instance, in moving or copying files between folders. Now, another way to copy a cell is with the fill handle. So I'm picking this one down here, C7, and there's a little square in the lower right-hand corner of the cell. That's called the fill handle. And when you're sitting on it, the mouse cursor shows as a solid plus. So if I drag that down one cell, it copies this cell down to that cell. We call that a drag copy, right? Another thing that's interesting is that if I select two cells with a 5 and a 6 here and do a drag copy, it recognizes that pattern and produces a 7 in the cell below 5 and 6. So that's a pattern copy. And we'll move on to look at down here where I put in a 1 and a 2. in cells A10 and A11. And then with those two selected, I double click the fill handle and I get a pattern extended all the way down to 750 items, all right? So that is very useful in certain cases. So I just reversed that. So that's a little bit in terms of copying cells, copying patterns, and then we can talk about moving cells. So a typical way, if I wanted to move this particular cell, would be to get on the edge of it and just drag it over and drop it. That's a drag move. Another way would be to use the Control X cut command, pick the destination and hit enter. And that accomplishes the same thing. Control X and enter or drag. And we quite often use the drag to move large blocks of cell so they're in a more convenient position. So if I get down here on B10 and do a Control A to select that entire block, let me do a tab and a back tab to come back to the top. I could take this entire block and I could move it one to the right and then use undo to put it back. So we drag blocks of cells. We could also do a Control X and an enter to move it. Quite often when we move cells, if it's going to wipe out contents of cells that are in the destination, Excel will warn us about that, okay? So that's a little bit in terms of moving around, copying, etc. So we're going to move on here and start getting involved in some simple formulas, what we call calculator formulas. So I'm going to either do File, New, right? Or I have a little shortcut up here to create a new spreadsheet document. And if I wanted to, I could come back to this one and just close it with the X in the upper right. And we'll come down to cell B2 and put in a formula, starting with equals, left parenthesis, SQRT, left parenthesis, 5, right parenthesis, -1, right parenthesis, divide by 2. So that's square root of 5 minus 1, quantity divided by 2, something called the golden ratio. Just as a curiosity, it's the only number where if I start another formula and take the reciprocal of that number, I get the same number except it's preceded by 1. And that's unique to the golden ratio. So when it has this particular formula, the way it goes about making the calculation is the first thing, if there are any built-in functions like square root, SQRT, it evaluates those first. And the next thing that it does is it evaluates any groupings within parentheses. So it would take that square root of 5 result and subtract 1 from it. And then after that, it's going to carry out operations from left to right generally, except that it has certain precedence in how it goes about doing that. So I want to pop over to a slide that documents that for you. So let's come back to our slides. These slides just review the settings that we made. And then these slides review the way we went about cell selection, jumps, selecting blocks, copying cells, and then copying using a drag copy or extending a pattern, and moving cells. So the slides are available to you so that you can review these things. And if any of them are new to you, I suggest that you practice them so they become second nature, because they'll just allow you to do your work more efficiently. And then here is the formula that we put in. And below that, I give you the order in which operations are carried out on the spreadsheet, starting with evaluating any functions, built-in functions like sqrt, evaluate the parentheses groupings, and then within the groupings, or for the formula overall, the order in which things are computed are first negation, not subtraction, but negation, or what is called unary minus, and then exponentiation, where we use the caret character, and then multiplication or division left to right, whichever occurs first, and then finally addition and subtraction left to right. So what I want to consider now is another formula. So let's come back over to the spreadsheet. Let me remove that formula with the delete key. And I'm going to put in the following formula: equals 12 divided by left parenthesis 1 plus exp minus 1, right parenthesis, right parenthesis, divide by 7 caret 1.5. And we get that as a result. Now, if I want to edit the formula or see the formula in the cell, it's always available up here on the formula bar. I can hit the F2 key, or I can double click in the cell and I will see the formula. And if you look down on your status bar, you'll see that we are in edit mode. What we mean by that is we can move the cursor back and forth across the formula and make changes when we're in edit mode. Looking at the formula and our rules in terms of order and precedence, we can see the first thing that we're going to do is we're going to evaluate the exponent minus 1, which is the Naperian e to the minus 1. And then we're going to add 1 to it because it's within those parentheses. Having that, we're going to start over here on the left, and we're going to divide that result into 12 as the next operation. And then if we look at that, we're going to say, well, we're going to do this exponent here, 7 to the 3/2 power, or 1.5 power. We're going to take that result and we're going to divide it into the left to the right result up to that point. So that's how we come up with that particular result. Now, it may look a little bit unusual to you because actually this first part and the second part are both in the denominator of like our algebraic expression. And if we would prefer to do it that way, we can come in here and we can surround the entire expression here with parentheses and change this divide to a multiply. And in this way, we see the entire denominator, and that will end up being calculated before it's divided into 12. And it should give the same result, and it does. So that just depends on how you prefer to do it, like repeated division or compute a denominator and divide it in. Either way will work, okay? A couple other things we like to point out is a very simple formula, equals minus 3 caret 2. Now, if we take a look at this, we might say, well, that should be 3 squared be 9, negated be minus 9. But you'll recall that the unary minus or negation happens first in Excel. So it's going to be minus 3 first, and it's going to be squared, and it should be 9. Now, if you didn't want that to happen, then you wanted to force a different precedence, you could enclose the 3 squared in parentheses, and you'd get minus 9. One thing I'll point out to you, in other computing tools, programming languages, typically this precedence is reversed. So if we go back to what we had, if we were computing that in MATLAB or Python, that would compute as minus 9. In fact, even if we were computing that in the companion programming language to Excel, VBA, it would be minus 9. But here, it's 9 because of the precedence rules for Excel. Another one, just to illustrate, I'm going to use 3 caret 2 caret 1.6. Now, because of the left to right order in Excel, that's going to square 3 first to get 9, and then take it to the 1.6 power. And we're going to get 33 approximately. Now, an issue with that is that if we look at this expression algebraically, 3 raised to the 2 raised to the 1.6, we might have a tendency to do the second exponentiation first, and then the first one second. And in fact, when you move to other programming systems such as Python, you find out that that's the way the rules apply. But here, it's not so, nor in VBA, nor in MATLAB. But if we wanted to enforce that, we can always surround the second part in parentheses and hit enter, and then we get that order of operation. And a different answer, of course. Okay, that's just a little bit on formulas. Now I want to review with you the size of the spreadsheet. So I'm going to, which is big, by the way. So I'm going to start up here at A1. And one thing I'll note that if I double click the lower boundary, nothing happens. But these things have slightly different personalities. So if I do a control down arrow, it goes down to row 1,048,576, which looks like a fairly weird number. But I'm going to put in a formula to the right of it, 2 to the 20th power. And we'll see that's what the number is computer folks like to think in binary, and 2 to the 20th is that row number, which is somewhat greater than 1 million. So 2 to the 20th down there, and let's come back home, control home, and let's do a control right, and we go over to column XFD. Now you can actually work that out, and that turns out to be 2 to the 14th, or 16,384 columns. Significantly fewer columns than rows, but usually big enough for the work that we do. So let's come back home. So what that means is that we have 2 to the 20th rows, 2 to the 14th columns. So the total number of cells that we have on the spreadsheet is 2 to the 34th, right? Now, it turns out that if we made an attempt to store a number in every one of these cells, storing a number requires 8 computer bytes, where a byte is 8 binary digits. So the total number of bytes required would be the number of cells times 8. And then we know that a megabyte is 2 to the 20th, and a gigabyte 2 to the 30th. So if I take this number up here, the total number of bytes, and divide it by the number of bytes in a gigabyte, we see that in order to fill an entire worksheet with numbers, it would take 128 gigabytes of memory, which is significantly more than we generally have in the central memory of the computer. But that's just a little bit of a picture of how big the worksheet is. And then, of course, we can have multiple worksheets. In fact, there are some workbooks that people use that have tens, dozens, even hundreds of worksheets in them. Okay, so let's move along, and let's come back to our little example of the golden ratio. Quarter to 5 minus 1 in parentheses divided by 2. Now we're going to deal with what we call cell addressing. So if I come down and over one cell to cell C3, and if I do an equal sign and point to cell B2 and click on it, it automatically enters the address B2. And if I hit enter, it replicates the number because it's referring back to cell B2. And then, these are important things to take note, is if I get on the fill handle and drag copy this down one cell, it gives me a result 0. If I double click on that formula, what we see is in dragging down my formula in C3, it also dragged down the reference of B2 to B3, which is empty, so we got 0. And this is called a relative copy, okay? So let's delete that. Another thing is if I take this particular cell, which is my formula, and if I move it down here, it still refers to cell B2. So moving my formula did not change the cell references, but copying the formula did change the cell references, and so that is something you need to keep in mind. And then what we do is we come to, let me move this guy back where it was here. We come to the concept of relative, absolute, and mixed addresses, all right? So if I take this particular cell here, and if I copy it, Control C to here and enter, we now see that it makes reference to C3, whereas this made reference to B2. So what happened when I did the copy is it moved the reference here down and over because my copy went down and over, all right? Now, let's go back and change that. And I'm going to open up this formula. And I'm going to change it by hitting the F4 key, F4. And that puts dollar signs before the B and the 2. You could have typed those in. I get the same result. But now if I copy this down to here and look at the formula, it still refers to the original cell. So the dollar signs provide it with what is called a absolute address, okay? Now we're going to carry a variation on that. So let's escape out of this and delete this. I'm going to come back and I'm going to remove the dollar sign from in front of the B. Okay? Get the same result. I'm going to copy it down here. And I got 0. So what happened? Let's edit that. And what you can see is in copying the formula down and over, it moved the reference from column B to column C, but it locked on to row 2 and did not move row 2. This is because of the dollar sign in front of the 2. This is called a mixed address. Also, we would call it relative column absolute row. All right? So let's get out of that, delete that, come in, and now let's go back to our absolute address, but remove the dollar sign in front of the 2. And enter that. And let's copy that down. We get a 0 again, but if we edit this, we now found that in copying our formula down and over, it copied the reference to B2 down to row 3, but it locked on to column B, which was absolute. And that's because column B had a dollar sign in front of it. So this is also a mixed address, and it is absolute column relative row. Okay? So let us come back up here, and let's go back to our relative address. Okay? And now what I'm going to do is I'm going to press the F4 key, which makes it into an absolute address. I'm going to press the F4 key again, which makes it into relative column absolute row. The F4 key again, which makes it absolute column relative row, and the F4 key again, which takes it back to a relative address. So let's come back to our slides and depict that for you. All right. These were the formulas that we showed you. Here is a slide that showed you how we computed the size of the worksheet. And then this had to do with moving and copying formulas. And this showed you how we changed the relative address to an absolute address and what happened when we copied it. And then this shows you the circular scheme that we can use with the F4 key to move amongst all the different addressing modes from relative, absolute, relative column, absolute row, absolute column, relative row, and back to relative. And then these were the exercises that we used to show you how you can illustrate how the referenced cell moves when you use mixed addresses, okay? So now we're coming back over to the spreadsheet, and we really don't need this one, so I'll get rid of it without saving it. And then I'm going to open a spreadsheet which is called Holland Moody Starter. Okay? And the reason you can see for this is that we set up some additional numbers on this worksheet, and we didn't want to take the time to do all of that now during the screencast. So what we've got are a series of columns which are labeled relative roughness and a series of rows which are labeled Reynolds number. And this is for the use of a formula called the Holland formula to compute the friction factor for flow in pipes, turbulent flow in pipes. And so this is the formula shown over here, and it uses a parameter here called epsilon over d, and that is the relative roughness. It's the roughness is the epsilon and d is the diameter of the pipe. And then RE down here is the Reynolds number. So what we want to do is implement a formula up here so that if we copy the formula throughout the table, it will make the appropriate references. For instance, this one over here will refer to this relative roughness and that Reynolds number. So let's see how we go about doing this, all right? So we'll start a formula with the equal sign, just looking at the formula over here. 1 divided by, left parenthesis, and then minus 1.8 times log 10. We're making use of a built-in function for logarithm base 10. And then another open parenthesis. And now, looking at the formula, we want the relative roughness, so we'll come up one cell. But when we copy the formula, we want that to be able to move across columns, right? But not move the row for that parameter. So if we hit the F4 key once, twice, that's going to lock that on to row 2, which is what we want. So we divide that by 3.7, close parenthesis, exponentiation 1.1, and then it's plus, as you can see, plus 6.9 divided by, and now we want the Reynolds numbers, so we go one to the left, but now we want to lock on to column B and let the row change. So we're going to go F4, 2, that puts the $ in front of the B, which locks column B, but not in front of the 3 because we want that to shift as we copy the formula. So now we do a right parenthesis twice, and then you'll notice there's a little exponential 2 at the end, so we do a caret 2. Now we do that, we get 0.0405 as the friction factor. And by the way, this is the Moody friction factor, which happens to be used a lot by mechanical engineers, and it is equal to 4 times the Fanning friction factor, which you may have run into in pipe calculations or your fluid mechanics course. So what I'm going to do is take the fill handle and drag copy this all the way across. And then I'm going to double click the fill handle to copy it all the way down. And this gives me a table of all the different friction factors for the corresponding values of relative roughness and Reynolds number. So let me double click this one, and you can see that it has automatically selected 0.01 and 100,000. Okay? So that's that, and it's an illustration, one illustration of how we might use mixed addressing in order to create a formula that can be copied appropriately. Now we're going to move on and consider doing things a little differently by creating names for cells instead of cell addresses. So I'm coming down to the bottom and clicking a plus for new sheet. And I'm creating a new worksheet in this workbook. Let me go to View, Zoom, and change the zoom down here with the custom button to 150%. Click OK. That just makes it a little bit easier for you to see. And what I'm going to do is I'm going to come down in column A here, and I'm going to type in some names. EPS, D, RE, and FM. And I'm just going to justify those in the alignment group on the Home tab. Okay. Now, I'm going to come to the right of the EPS label in cell B2, and I'm going to come up to the name box and click once and type EPS. Now that cell certainly is B2, but it also has a name associated with it, which is EPS. If I click over here and bring the drop-down arrow on the name box down and click on EPS, it immediately takes me to that cell. So I can create a name in any cell using the name box. Another convenient way to do it is, I'm going to illustrate here. In fact, I'll do it with all of these. And that is that I'm going to transfer these labels as names on the cells to the right. And the way that I do that is I go to the Formulas tab, and in the Define Names group, I click on Create from Selection, and it says Create Names from Values in the left column, which is what I want. So I click OK. Okay, and so I've got D here, RE here, and FM here. So you can transfer names over, and they will then be on those cells. Whenever you transfer labels as names, it's always good to go and click on the cell and look up in the name box and make sure that everything happened correctly. So what I'm going to do is put in some values here now. 4.5 e to the minus 5. And I'm going to put a label for units over here, meters. And that happens to be the roughness of standard carbon steel pipe. And then I'm going to put in a value 0.0525 meters, all right, which is the inside diameter, I believe, of a 2-inch Schedule 40 pipe. And then I'm going to put a Reynolds number in of 10,000, just so I have values to work with. Now I'm going to recreate my formula for the friction factor using the Holland equation. So it's going to be equals 1 divided by left parenthesis minus 1.8 times log 10 left parenthesis. Then I'm going to click on the EPS value up here. And you'll notice when I click on the cell, instead of entering the cell address, it enters the name automatically. Divide by D. I just typed the D that time, but I could have clicked on the D cell. And then divide again by 3.7, right parenthesis, caret 1.1 plus 6.9, divide by, click on the RE cell, and it puts that in with its name, and then 2 end parentheses, caret 2. Now, a main point being made here, first if I hit enter, I hopefully get a value, all right? The point being made here is that when we look at that formula, we see variable names which look familiar to those that are in the formula we may have in a reference shown algebraically. So it makes it much easier to debug rather than looking at cell addresses and having to translate cell addresses into variable names. So this leads us to a very strong suggestion, and that is whenever you are creating spreadsheets, you want to make use of cell names to the greatest extent possible. Okay? Now, cell names can also apply to blocks of cells. So we're going to open up another file, which is called block data. And we're going to select all these data. And I'm going to put in a name, capital P data, no spaces there, just capital P data, as if these are pressures, for instance. And then I'm going to come down and create a formula down here, equals average of P data. And it's 14.79. So I can name a block of cells or array of cells with a name and then use that. And a very useful feature of that is that if I were to take these data and move them elsewhere, the formula still worked because by moving the data, the name moved with them. Whereas if I had a formula here in terms of cell addresses, that would not be the case and I'd be in trouble. This comes back in spades when we work with VBA, where we want to avoid the use of cell addresses to the greatest extent possible, because otherwise changes on the spreadsheet can immediately invalidate our computer code. Okay, so we'll show you one additional feature here, and I can do it on this particular workbook if I want by just adding a worksheet. And once again, let me change the zoom to 150%, or try. And then I will just put in a couple numbers here. And I'm going to put in an expression to the right using a function that we have not illustrated yet. And that's the if function, equals if. And the if function has three parts to it. The first part is a logical expression or test. So what I'm going to do as the test here is if B2 is less than 0, comma. In this case it is, but not always. And if it is less than 0, then what I want to do is take a minus sign of B squared. So I'm squaring it and I'm preserving the sign. And if it is not less than 0, I'm just going to square it. So the syntax for that is if logical condition, then what happens when it's true, and then what happens when it's false. In this case, we get a -9, and if I copy this down, we get a 9, because the 3 is positive. If I copy it down again, we get a 0, because it's not less than 0, and it squares 0 to get the answer. So the logical expression that we've got here, I'll just put it in over here, equals B2 less than 0, comes out to be true, and then false, false. So here we see a little difference because we have a formula that is a logical expression, which means that it yields a result which is either true or false, and those symbols, true and false, are reserved in Excel as logical constants, true and false. Now let's come back to our slides. This is the example that we showed where we created the formula using mixed cell addresses that could be copied throughout the table. And that's illustrated here. And then we went on and we created names, either by typing into the name box or by using Formulas tab, Create from Selection, by selecting the label cells and the cells to the right. And then we make a comment up here that you need to keep in mind. And the first one is probably makes sense, although it's an easy trap to fall into, is that you cannot create names that are also cell addresses. So if I've got a cell that's something like a mole fraction, and my equation shows that as x1, I cannot create a name x1 for that cell because there's another cell which address is x1. Now, an alternate there is to use something like x_1, which we often do. Also, another idiosyncrasy is that we cannot use names that are solely the letters R and C, nor can we use names that involve R and C followed by any numeral. Now, the reason for this harkens back to an old way of addressing cells in Excel called the RC addressing scheme, where you provide a row number and a column number. And we don't use that anymore, but the legacy is still around in preventing you from using those names. So this is how we put that together with the formula and got the result that we showed. We also showed you how we can create a name for a block of cells, P-data, and that is illustrated here. And then finally, example of the use of the if function based on a logical expression and a true and a false option. Now that brings us to the last part of this first screencast for Bootcamp 1, and that is just to review how logical expressions are put together. And they're based on the use of relational operators and logical functions. Now, some other computing systems or programming languages actually have logical operators, all right? And VBA has these. But in Excel on the spreadsheet, the logical operations are handled with functions. So the relational operators, where you compare two things and get a result, are equal sign for, equal to, the less than, greater than pair for not equal to, and then the typical ones for greater than, less than, greater than or equal to, and less than or equal to. And then the logical functions are not, and, or, and exclusive or. Now, the one there that might look a little bit strange to you is exclusive or, because an or function would give you a positive, a true result if either one or the other is true, and the exclusive or will include a true result if both are true. So we have this down here, which is the illustration, an illustration we have where we apply, and this is, by the way, the order in which the functions are applied unless it's overridden by parentheses. So what we have are a couple of relational expressions here. Is B6 less than C6? And that's false. And is B7 greater than C7? And that's true. So we've got a false and a true with an and, which will give us false, but then we reverse that with the not function, and a false becomes true. And that's what's shown down here. Okay, so we're going to call our screencast to a close, and then we'll pick up in the next one and do the part of the first bootcamp for Excel and VBA that involves the creation of plots. So that's it for now.